So now I want to take you on a state-of-the-art journey. You know, as we built this plant, we traveled around Europe, the United States, and we tried to find the best technology for Unifi. You know, one thing that Unifi has always done throughout the years is we've always been leading the way in innovation and leading the way in technology. When we started the process, when we looked at this extrusion, we did many different tests at many different manufacturers. We wanted to get the right fit, the right technology, so that we could be the best at polyester recycling extrusion. So why run an MVT on our new equipment? We were new at this to some extent. I had some experience with some other suppliers with their extruders, but from a Unifi standpoint, we were totally new. All we had was the acceptance test from our manufacturer that we bought the equipment from. They brought their head process engineer in. They had actually set up a process, and they said, hey, this will get you what you need. We couldn't just stop there. We wanted to know the true machine capability and what it could do for our process in recycling. This is our hybrid line, which we actually take post-industrial and post-consumer raw materials and make it into a pellet form that goes into our fiber. Over this machine, if you look at what we had over 75 linear feet of mechanical extrusion technology that we had to look at. There's a lot of moving parts. There's a lot of gears. There's a lot of pistons. There's a lot of things on this machine that we wanted to know exactly what it would do in our process and get the very best process for our customers. So one thing we did is we took the 14-step approach. So we started from ground zero, and we wanted to know how it would affect our process. As you can see, I had a great team, very, very good people. We had some process improvement engineers, all the way down from myself as a plant manager, the operations manager, all the way down to the wage employees on the floor. If you don't utilize those wage employees on the floor and the people that are actually running the machinery, sometimes you'll get in bad shape because they know exactly how to run these machines. What we did through MVT number 1, as you can see, was step 7 of that 14-step process. We wanted to establish our process. We wanted to identify the gaps in our process with the MVT. Since we were new at the recycling extrusion, as I said, we wanted to take it all the way through the 14th step. Through this machine characterization, and that's what we call this MVT, is because we wanted to characterize every button, every knob, every set point, so that we knew from that point on that we could feel very comfortable in what we were producing. If we had have taken the stance of doing the old one factor at a time method, it would have taken us over 8 million combinations to be able to achieve what we did through this MVT, which was 64 unique recipes. That's pretty amazing. One thing I can say through my technical experience is a lot of times throughout the years, and that's one thing that this kind of hits home with me, is we would always turn one knob, or we would always test one thing. Being able to actually bring this in, utilize this 64 unique recipe combination with an MVT, be able to take those factors, see what those interactions are, see what the machine capability is, the true machine capability. That's really what it's all about. Every set point on the machine became a factor. We actually had 27 factors that were practical, that were fast, and were cost-free. Our key measures through this was actually viscosity. One reason we had viscosity in there is because taking our pellet to our filament fiber plant, our viscosity, and viscosity actually is the strength or integrity of the polymer. What we have to maintain a certain viscosity in order to melt it and actually get the properties and characteristics that we want in fiber form. So that was one of our key measures throughout this MVT. Another was our color test. We actually look at the whiteness of the product, the whiteness index. One thing that our customers want and they're pushing us for is a whiter product. The only way that you can do that is you got to go all the way back to the raw material through. So we wanted to test color and see where we could be on the whiteness of our pellet going into fiber. And then last but not least was filtration. As we put this through our filament fiber plant, we want it to be free of impurities, free of contaminants, so that we can get a stable process and we can get a stable product throughout the texturing process. And then we come to the results. We had that many helpful factors right off the bat that we could actually go back into our machine setup. We could make those changes and we could benefit from this MVT. MVT number 2 was more of process improvement because, as you could see on MVT number 1, we knew what to adjust on the machine, what would help us, what would hurt us, and we went ahead and applied those across the board through our procedures so that we knew the product we were getting was a good product in the end. So now we're trying to improve the process through MVT number 2. On this MVT, since we knew a lot about the process from the first one, we were able to stretch those factor limits. We was able to go bolder with our temperature set points. We were able to go bolder with our throughput. We were able to get a little more creative. Screening MVT results for number 2. As you can see, we already had the helpful factors and the hurtful factors from MVT 1. So after we run it, we see more helpful and hurtful factors that were significant. So one thing we were able to do is we could go back to our process again. We could set it up to where we had a stable and consistent process based on this data. We were able to make some changes and modifications so that we could drive that color of the pellet whiter and the final fiber whiter. Our second MVT generated more good ideas, as you can see by all the helpful and the hurtful factors that would help us attack all these issues that we were seeing and get a stable process to where we could run a very efficient and good product. We're much more confident now. We can actually take these documents. Even as I'm the plant manager, if I leave tomorrow, we have these documented results that whoever steps into my place, an engineer that comes in the next day, it's not going to be stuck in my head. It's not going to be in my engineer's head. It's actually going to be documented results that we can actually take to the company and everybody can utilize, which is a key. We have seen the value of MVT within our company. So we're not stopping just at what we did on this one machine. We also have a filtration MVT coming up in the next week on our post-consumer line that's strictly 100% post-consumer recycled products. One thing that we were dealing with going through our plant process is the filtration, trying to get the contaminant out of that post-consumer type material. There's a lot of milk jug or polyethylene, some low melt materials that can actually cause problems in the polymer itself. So we're trying to get more creative and more advanced in filtration. This is going to allow us to do that. One thing that our CEO has actually given us over our COTs is the REPREVE product characterization. One thing he's wanting to see is he's wanting us to take it from the raw material that I have all the way through textured fiber and then ultimately all the way through some of our customers and be able to map this whole process out so that we can get the best product for our customer. I can tell you it's been a great experience for me. It's been like I said, it's been an eye-opener. I was a little skeptical at first, I'll be honest, because I came from that, one factor at a time methodology and trying to push one button or turn one knob. And, as we implemented this, we have seen those results. So I can tell you it is real. Through this MVT or these 2 MVTs, we're able to drive our costs down somewhat because our waste percentages are going to go down. Our first pass yields are going to go up. I mean, and it's a given. I've already seen that through the plant. Actually, 28% increase in throughput we actually made through this entire process.